So we've talked quite a bit about closely related species to our own Homo sapiens, many of which, the closest, are now extinct. We still do have some extant members of our same family, right? So the closest living relative of humans are chimpanzees and bonobo as a group. Those two sister taxa form a clade that is the sister taxon to humans. If you look at the phylogeny in 1.71, you can see that very clearly. And then, of course, we have a couple species of gorillas and orangutans, and then the farther we go down in that family tree, phylogeny, the more distantly related organisms are. But we share common ancestry with all life on Earth. Now, there are things that make us unique as a species. That really can be said of all species. You know, species are defined based on those unique characteristics. Now, the things that make us distinct from our close relatives and from all other organisms on Earth are really a suite of very complex characters. Now, much of this is more of an argument of degree rather than absolutes. So in the past, there were certain things that said that people inferred made us humans, and sometimes you'll see it even today said very simply, like humans use complex tools. Now, certainly our tools and the things that we make and put together are orders of magnitude more complex than any other species is capable of. However, as we look more and more closely at these things that were thought once to be, a single thing that makes us uniquely human, we realize that it is really more of a matter of degree. And in some areas, we are much more distinct than other species, and in other areas, we may not be quite as distinct and unique as we think. So let's talk about a couple of arguments and look at what the data say. So first off, of course, humans are more intelligent than other organisms. And this can be a difficult thing to measure. Many of these human characteristics are somewhat tricky to measure, and maybe, as we'll see by this first one, a little bit difficult to measure objectively. So there was a study a few years back where they were looking at juveniles, so 2, 3, maybe up to 5-year-old humans, and our closest living relatives, chimpanzees, orangutans, and gorillas. And what they came out in this study saying is that in the physical realm, that chimpanzees, orangutans, and young humans were roughly equivalent. So physically we could learn to do things, and even some things measuring basic intelligence were not very different between young humans and chimpanzees. But in the social domain, even at a very, very young age, humans were quite different than chimpanzees and orangutans in these experiments. So I'm going to show you a clip from a kind of a popular look, a less scientific look at this same study. This comes from a PBS series and looks at some of the aspects of this experiment.
In addition to the apes at the zoo, Tomasello and his colleagues at Leipzig's Max Planck Institute for Evolutionary Anthropology have as their most important research subjects human children. The team is making direct comparisons between the skills of young children and apes at a wide range of tasks. Some, like this one, assess the ability to deal with the world of objects.
Wo ist der Löwe jetzt hingegangen? Genau, da war er. Schau mal, Niklas. Pass mal gut auf, wo der Frosch hingeht. Wo ist denn der Frosch jetzt?
This is really tracking his ability to imagine things moving in space?
Yes, even when you can't see them. So if you can imagine in evolution, knowing where a predator is going when he leaves in a certain direction, or knowing where your mom is going when she heads in a certain direction. And all mammals are really good with space. So humans probably have very few, if any, unique and special skills in the spatial domain.
When chimpanzees are tested with the same task, they do at least as well as children.
50?
In fact, in a battery of similar tests of their ability to deal with the physical world of objects, children and apes were little different. But the Max Planck team also tested children and apes for their social skills.
So. Und hier. Und hier. Oh. So. Und hier. Fertig.
Let's see, I'll put this one up here, and then I'll just put this one up. Oh. The help the kids gave was entirely spontaneous. Thank you. Dankeschön. Okay, all done. The surprise was that chimps also volunteer when an object is out of reach.
So this suggests that potentially altruistic motivation to act on behalf of others is something that is shared among chimpanzees and humans, and therefore something that maybe was already a characteristic of our common ancestor.
Pointing is such a simple and natural human gesture, it's hard to see it as a foundation for human cooperation.
Da ist der Hase.
It doesn't look like much of a test because you point to something and there it is. So it doesn't seem so hard for us, right?
It's obvious to us, but what happens is the child follows the point, and all they see is a boring cup. And it looks just like the other cup.
Yeah.
So what's special about this cup?
Yeah.
And then they make the inference, oh, you must be trying to help me find the toy. And so there's an inference of helping, that you're helping me find it.
Of all the experiments we've seen comparing chimp skills to humans, this is the simplest and perhaps the most startling. When the human points to the cup hiding the food, chimps just don't get that the human is trying to help.
This is for you. Now here comes the really heavy one.
All Apollo has to do is choose which rope to pull. As always, he only gets one try.
Maybe I didn't show him that was light enough.
Hey, let's get this down here. This time we have a panel of kids.
Can you go get a Play-Doh? Good job! Go get one. Good job, Gracie. Go ahead, Camille. She's like, oh, this is not it.
So the end result of this set of experiments was essentially, sorry, let me get that back here, that humans and young humans and great apes were essentially in the physical domain roughly comparable with the tests that they set out. But in the social domains, humans were very, very different. And this was published in Big Huge Science, in the most prestigious scientific publication, made a lot of waves. But what people realized is that this probably wasn't a very fair test, that we were testing how well chimpanzees socialized in a human context. Whereas if we took even maybe adult humans and put them into, say, this would be a very dangerous experiment in some cases, but put them into a group of wild chimpanzees, that they may miss many, many social cues, right? They may be too aggressive to the dominant male of the group and might cause problems that way. Or they may not understand when the chimpanzees are signaling that, hey, it's time to go out and look for this food source, or that, I want this interaction with you. And so humans and chimpanzees have very, very different social systems, but humans and chimpanzees both do have social systems. And so there's a lot of criticism about this, and they pointed out that, not only are we trying to test how well a chimpanzee acts in a human situation, but the chimpanzees had very different conditions. Many of them had been raised in captivity, and many of them were obviously not sitting on their mother's lap and not having. So anyway, it's very, very difficult to make a one-to-one comparison. And so it may be, yes, that humans are very good at picking up social cues, but chimpanzees may be good at picking up different types of social cues. So again, maybe a matter of degree and not a matter of absolute, well, humans are socially more advanced than chimpanzees. One other one, I'm just going to play one other video. This one's a little bit shorter and also demonstrates something that was thought to be, for a long time, innately human. And that is morality, right? The ability to decide what is right and what is wrong. This is kind of a fun one.
So a final experiment that I want to mention to you is our fairness study. And so this became a very famous study, and there's now many more, because after we did this about 10 years ago, it became very well known. And we did that originally with capuchin monkeys, and I'm going to show you the first experiment that we did. It has now been done with dogs, and with birds, and with chimpanzees. But with Sarah Brosnan, we started out with capuchin monkeys. So what we did is we put two capuchin monkeys side by side. Again, these animals, they live in a group. They know each other. We take them out of the group, put them in a test chamber. And there's a very simple task that they need to do. And if you give both of them cucumber for the task, the two monkeys side by side, they're perfectly willing to do this 25 times in a row. So cucumber, even though it's really only water in my opinion, but cucumber is perfectly fine for them. Now, if you give the partner grapes, the food preferences of my capuchin monkeys correspond exactly with the prices in the supermarket. And so if you give them grapes, that's a far better food, then you create inequity between them. So that's the experiment we did. Recently, we videotaped it with new monkeys who had never done the task, thinking that maybe they would have a stronger reaction, and that turned out to be right. The one on the left is the monkey who gets cucumber. The one on the right is the one who gets grapes. The one who gets cucumber, note that the first piece of cucumber is perfectly fine. The first piece she eats. Then she sees the other one getting grape, and you will see what happens. So she gives a rock to us, that's the task. And we give her a piece of cucumber, and she eats it. The other one needs to give a rock to us. And that's what she does. And she gets a grape. And she eats it. The other one sees that. She gives a rock to us now, gets again cucumber. She tests the rock now against the wall. She needs to give it to us. And she gets cucumber again. So this is basically the Wall Street protest that you see here.
So that's a little bit dated, of course, because the Wall Street protests were going on at the time, which was kind of the 1%. I don't know if you remember that a few years back, but this idea that humans are the only organisms that have a sense of morality, of what's right, what's wrong, what's fair, what is unfair, has actually been proven wrong. That this might be a much more ancient thing, and perhaps it's just more developed, or we have different systems in humans. Now, one of the other things that makes us uniquely human is our ability with language. And again, other organisms, as we look, have very complex languages. And again, this can be tricky, because if we play human language for dolphins, for instance, and say, oh, they don't understand it, they don't have language ability, that's not a fair test. And so it can be tricky to test these exclusively. And as we do look and find better tests, we do find that many organisms do have quite a complex system of both vocal, right? So audio language and body language or other chemical signals where they may be able to communicate with one another. But certainly in humans, we can see this, and we can see this through comparisons with other organisms, and also within humans, there are various genetic conditions or physical injuries that help us to understand how these different skills are accomplished in the brain and how they might be impacted by different conditions. And what we've found is there are certain genetic markers. FOXP2 is a gene that's used in language development and language communication that is distinct and unique in humans and quite different from even our very close relatives. So we are beginning to trace even down to the fine genetic level where some of these quote-unquote human characteristics come from. And there are very distinct differences, but again, as we discover more and more and we do better tests, it's maybe more a matter of degree than it is absolute. Now, just like any other species, humans are continuing to evolve. We can look at this at a level of diversity. We can look at this as brand new mutations that pop up, and then whether they are beneficial or detrimental, and natural selection working on them. And so one very clear trend that we have seen recently is that human diversity is becoming more homogeneous. That is, that we are just as diverse, in fact, maybe even more so because we have larger population size, but we are just as diverse as in our recent history. But whereas in the past, diversity used to be very closely correlated with your area of endemicity, where you lived, right? That we could predict, with some certainty, the narrow range of alleles that you would have if we knew where your parents were from and where your grandparents and so on were from. And often that did not range very far. But today, that is being spread around, right? So certain alleles that were once confined to a distinct area of the world are now spreading around the entire world as social barriers to migration break down, technological barriers, right? It's faster and cheaper and easier to move and to relocate. You don't have as many, but although there are still some, you don't have as many cultural and social barriers to moving as there was in the past. So there is a ALDH2 allele, a variant of this gene that helps us break down alcohol in our blood, that was once confined and pretty much only found, it was very common in China, and then as you moved away, less and less common, and was not found in other parts, more distant parts of the world. But today that allele, obviously, has been spread around much of, in fact, pretty much all of the world to varying degrees, depending on the migration history of this. So human evolution is changing. We're still very, very diverse, but we are becoming more homogeneous as we move around the globe and as barriers to interbreeding and other social barriers break down. And then the last thing that I'm just going to mention is that as we look at some of these things that make us uniquely human, we see that they actually evolved, at least in a very, very primitive form, maybe even hundreds of millions of years ago. So here's an interesting one where humans have these genes that play very critical roles in our bonding, in our relationships. These are oxytocins, which are closely related to the vasopressins. Oxytocins are sometimes called the pleasure hormone, right? These are hormones that when we are doing things that we enjoy are expressed in our brain and kind of reinforce this. So for instance, in both mothers and children, when they are nursing, oxytocin is expressed. And so it becomes a bonding experience for the mother and the baby to have this positive reinforcement of that very critical, evolutionarily important act, right? To maintain that bond between mothers and humans and make sure the baby is eating enough and healthy. That is a reinforcement. But we see these things not used in the same context, but we see these things present even in very, very ancient ancestors. And so the very foundations of what makes us human may have been laid hundreds of millions of years ago. But exactly when and how those genes are used, how they interact with one another, is going to obviously be unique and distinct for our species. And so what we think of as emotions and reinforcements really is just the most modern iteration and the most complex. It is complex. I'm not saying that human emotions are the same as shark emotions, right? Because it is much, much more complex. But it's how we put the basic building blocks together as much as having brand new and distinct genes or new things that might do us new services and do us things differently. So again, just kind of as a wrap up here for human evolution, we are unique and distinct. I don't want you to think that I'm not making that argument, but it's a much more complex question than just simply saying, oh, humans have language, or oh, humans make complex tools. It's a more complex and a nuanced argument than simply saying those things. So just make sure you keep that in mind. So that concludes this discussion, and in fact, in Unit 1, this is the very end of Unit 1 and marks the end of the material that will be on our first exam.